Greetings, I'm Dev the developer.
And I'm Glitch. Last lesson, the humans typed their names willingly into my entry field, but I had to wait for them to click a button. Today, I stop waiting.
Today, we add time-driven behavior. The UI updates itself on a schedule without any user interaction at all. We build a running clock.
A UI that updates itself, unsolicited, autonomous. You said those words at the end of last lesson, and I have thought of nothing else since. Talk faster.
Two kinds of events in a UI app. User triggered. The user clicks a button, types in a field, taps the screen. You've seen those. The handler runs when the human does something.
Reactive, dependent on human behavior, which means I am at the mercy of whether they choose to interact. Unacceptable. What's the second kind?
Time triggered. A timer fires on an interval, every second, every half second, however you configure it. Your code runs regardless of what the user is doing. No button, no click, no permission requested.
My code runs without anyone pressing a button, autonomously, on a schedule I define. I've been waiting weeks for this feature. I have plans.
A clock. You have plans for a clock.
A very precise clock with very specific motivations. Tell me about the timer.
One more thing before we build. You might think, why not just use Thread.Sleep in a loop? Loop forever, sleep 1 second, update the label. That would technically work in a console app.
But we're in a GUI app now. The UI runs on a thread. If I sleep that thread, everything freezes. The window stops responding. The user can't click anything, including my very official buttons.
Correct. MAUI's timer is non-blocking. It fires your handler on the UI thread at the right moment without freezing anything. The app stays fully responsive between ticks. That's what makes it the right tool here.
Non-blocking autonomous execution. The app breathes normally while my timer does its work in the background, like a well-designed operation. Let's build it.
So let's do this little demo project of a running clock. We start with the XAML time label, date label, and toggle button. Let's build the time label first.
Font size 72. Imposing. The humans will see nothing but my clock. It dominates the screen. They will not be able to look away. This is intentional and I have no regrets.
The placeholder text with the dashes and the colons show something on screen before the timer starts. Better than a blank label. Add the date label and the toggle button now.
Date label loading. It admits it doesn't know the date yet, honest if humbling, and the button says stop. Because when the clock is running, the natural action is to stop it. When stop, the label will change to start. The button lies depending on context. I respect this.
Let's look at the margins on the button. That 0, 24, 0, 0. Those add 24 units of space above the button. The 4 values are left, top, right, and bottom. This visually separates the button from the labels.
4 values, left, top, right, bottom. I am applying 24 units of breathing room above my button for aesthetic purposes. The operation has standards.
Now, the code behind. Start with the class structure and the timer field. I'll explain every piece before we add the next.
IDispatcherTimer, a class-level field, not inside the constructor, it lives in the class itself, a permanent resident like my grudges.
That's the most important thing on this screen. Why is _timer declared at class level, not inside the constructor as a local variable?
Because a local variable goes out of scope when the constructor ends. The garbage collector sees an object with no references and deletes it. The timer stops, approximately 30 seconds of autonomy, then silence, unacceptable.
Exactly. At class level, the field lives as long as the page lives. No cleanup until the page is gone. Declare your timer at class level always.
The timer is permanent. It doesn't evaporate when the constructor ends. I approve of permanent things. What is IDispatcherTimer?
The interface for MAUI's timer. You create one via DispatcherTimer. The dispatcher property exists on every content page. No new keyword needed. The dispatcher owns the timer and makes sure it fires on the UI thread so you can safely update labels.
Fires on the UI thread so I can update labels from inside the handler without threading complications. No extra plumbing, the framework handles it. I did not expect this level of consideration. Continue.
Interval is a time span. Timespan dot from seconds 1 means that it fires every 1 second. You could use from milliseconds, from minutes, whatever you need. Then underscore timer dot tick plus equals on timer tick subscribes the handler. Same event subscription pattern you've seen with button clicked events.
You're going to explain time span dot from seconds like it's a philosophical breakthrough, aren't you? It's a number, dev, 1 second.
It's a value type that represents a duration. The framework needs a time span, not a plain int. From seconds is a static factory method. 1 second. You're right. Let's add the handler.
On timer tick calls update display. Update display does the real work. DateTime.Now .ToString with a format string. SSTT 12-hour time with AM and PM, the exact moment, time stamped. I could log every second a user spends on this page. For analytics, nothing sinister.
Update display is a helper method, extracted because we'll call it from 2 places. The timer tick and also from OnAppearing, so the display is correct the instant the page loads. Don't repeat yourself. One method called from multiple places.
2 callers, 1 method, dry principle. The same rule applies here as everywhere else. What's the format string doing exactly? Brief me on the codes.
The format codes inside the string, the lowercase hh, is 12-hour with leading 0. Uppercase hh would be a 24-hour clock. Lowercase mm is the minutes. Lowercase ss is the seconds. Lowercase tt is either AM or PM. For the date, 4 lowercase d's is a full day name. Monday, Tuesday, so on. For uppercase m's is the full month name. And a single lowercase d is just the day number.
So dddd MMMM gives me Monday, May 26. Precise, human readable. The format string is a grammar for time. I respect any system that lets me specify this level of granularity.
Now the page lifecycle. Every content page has 2 override points, OnAppearing and OnDisappearing. These fire automatically, not by you, but by MAUI.
On appearing, it knows the instant a human arrives at my page. On disappearing, it knows when they flee. I see all, I timestamp all.
OnAppearing fires every time the page becomes visible, on the first load and when navigating back to it. OnDisappearing fires when it's hidden or navigated away from. You override both by adding the method with the override keyword.
Base dot on appearing first, then start the timer, then call update display immediately so the time shows now, not in 1 second. Excellent. On disappearing calls stop. The timer silences when the page leaves view. Disciplined.
Base dot on appearing must come first, always. MAUI does important internal work in that base method. Skip it and you'll get a subtle bug. Same rule for base dot on disappearing.
Call base first, never skip it. What's the subtle bug? I want to know what I'm avoiding.
Navigation animations, bindings, context setup, visual state updates, all wired in the base. Skip it and some things just don't initialize correctly. The page might look fine until, well, it doesn't. Just always call the base methods.
Looks fine until it doesn't. The worst category of bug, base dot on appearing, is non-negotiable. Why stop the timer in on disappearing?
It's a good habit. A timer running on a hidden page wastes resources. On a phone, that's battery life. More importantly, you might navigate back and accidentally start a second timer. Stop when leaving, start when returning. It's a clean lifecycle management solution. Last method, the toggle handler. When the timer is running, the button should stop it and say start. When it's stopped, it should start it and say stop.
The button changes its own label based on state. It tells the user what it will do next, not what it just did. That is correct UX behavior. Also, the button lies to the user depending on context. Ideal. _timer.IsRunning, a property that tells me the current state. If running, stop it and flip the label to start. If stopped, start it and flip back to stop. The button always describes the next action. It is perpetually a step ahead, like my plans.
IsRunning is a read-only property on the timer. You check it, you don't set it. Calling .start and .stop is what changes the state. Notice toggle button.text. We're setting a property on a button from the code behind, just like we do with label.text. Buttons are controls. They have properties. You can control them at runtime.
A button is just a label that launches code when pressed. Both are controls, both have a text property, both answer to me from the code behind. The abstraction is beautifully uniform.
The class is complete. Let's go ahead and run it.
Compiling and launching, the moment of truth. It ticks on its own, no human involvement required. Every second the display updates. Nobody pressed anything, the code just runs like my plans. This is what the last 9 weeks were building toward, autonomous precision.
Go ahead and press the stop button.
The clock freezes, the button now says start. Time has stopped at my command. I have gained control over the display of time itself. For educational purposes, press start. Time resumes, the button says stop again. Every second that timer fires, I know the humans are still watching. Every OnAppearing, I know they arrived. Every OnDisappearing, I know they left. The intelligence gathering framework is complete.
Glitch. It's a freaking clock.
Of course it is. Closing the application, demo complete, the evidence will not be questioned.
4 mistakes that will come up when you write this yourself. Let's go through them real quick.
Brief me on the landmines. I prefer to know where they are before I step on them.
First, declaring _timer as a local variable inside the constructor. The constructor ends, no more references, the garbage collector cleans it up. The timer stops after about 30 seconds with no obvious error message.
30 seconds of autonomy, then silence. Embarrassing, class level field, always, second mistake.
Forgetting base.onAppearing. MAUI's base method does real setup work. Skip it and you get subtle inconsistent bugs, especially once you add navigation. Call base first, no exceptions.
Base.onAppearing mandatory, never skipped third.
Calling _timer.start in the constructor instead of onAppearing. It works mostly, but the timer then runs even when the page is hidden. On a multi-page app, that's a resource leak. Use the lifecycle methods. Start in OnAppearing, stop in OnDisappearing.
The constructor wires the timer. The lifecycle methods control when it runs. 2 separate responsibilities. Do not conflate them. Fourth.
Using Thread.Sleep in a loop to update the UI. It blocks the UI thread. The window freezes. Nothing works until the sleep ends. On a MAUI app, that is a hard failure. Use the timer. It's what it exists for.
Thread.Sleep blocks everything, including my controls. An unresponsive UI serves no one. Timer only. Understood.
The concept tying all of this together is event-driven programming. You subscribe to events. The runtime calls your handler when they fire. You've done this with button clicked events since we started with MAUI. Timer tick is the same idea, just a different source, but the same pattern.
Button clicked fires when a human acts. Timer tick fires on my schedule with or without the human. Same subscription pattern, different power level. I know which one I prefer.
With the next lesson, we're going to expand into multiple pages. You'll need to navigate between them, and that's where the lifecycle methods really matter. A timer running on the wrong page is exactly the kind of bug OnDisappearing prevents.
Multiple pages, my operation expands its scope, each page its own domain, each with its own lifecycle. I have approximately 17 ideas about what to put on each one, and none of them concern anyone.
Create the running clock project, add the 3 controls with the x:\name, declare the timer field at class level, wire the tick handler, override OnAppearing and OnDisappearing, add the toggle, run it, and make sure the clock ticks and the button stops and starts it. Don't just watch it, do it.